Good morning from Baton Rouge, Louisiana. I'm Dr. Meredith Warner, founder of Well Theory, Healing Soul, and Warner Orthopedics and Wellness. And today we're going to talk about one of my favorite subjects, oxidative stress. Just to warn you, this is going to be a little bit high on the science in the beginning, but I think that everybody out there is certainly as capable as anybody else to get this and understand it. We're just not told about it. And I had to sort of reteach myself. I think we were taught oxidative stress for a second during medical school, and that's about it. And I've sort of relearned about it in the past couple of years on my quest for total health empowerment for my patients, my friends, and my family. This, I think, is one of the core issues, fundamental issues with our health these days. And unless you really understand it, nothing else that I say or other physicians might say about reducing inflammation and whatnot, it's not going to make sense unless you understand why this matters. And there are different theories on aging, of course, but I think at the end of the day, oxidative stress does matter for overall health and wellness. So we'll get started. So again, I'm Dr. Meredith Warner of Warner Orthopedics and Wellness, and I like to do this as often as possible, which right now for me is really only once a month because I am also running a clinical practice at the same time. But I do enjoy teaching, and I want people to understand their health so that they can make good decisions. Okay. This is sort of some of the offerings we have at my clinic. I try to promote non-operative care, musculoskeletal problems, if at all possible. We do operate, of course, if it's necessary. But a lot of surgeries done today, I think, are probably unnecessary in terms of the actual clinical outcomes. You can achieve the same clinical outcomes with much less cost and much less risk. For any given diagnosis, if you will. Not to say surgery is totally not necessary, because certainly I love to operate and we do surgery. But there's certainly other ways to treat pain in particular and different functional issues. And then as far as wellness is concerned, there is no surgery that's going to make you well. You're going to have to do it yourself, and I'm going to give you the tools. All right, so here's my clinic. I try to make it lots of natural light. All the lights are daylight spectrum, and this is all by design and for reasons. Daylight spectrum promotes health. It reduces infection rates. UV rays are known to be, at a certain frame length or wavelength, I should say, and for limited time, beneficial versus always having yellow light around a red light. Now, you don't want to stare into blue light all the time, of course. These are blue light blockers. All my glasses now are blue light blockers to try to prevent eye fatigue and prevent macular degeneration because of oxidative stress on the retina. But you get the picture. We just try to promote a feeling of health, family, a sense of belonging, and a sense of empowerment. So today, oxidative stress. You may or may not have heard of this. If you talk to me, if you come to my clinic, or if you've seen my work before, you know that I'm a big believer in the badness of oxidative stress and chronic inflammation in terms of overall health, wellness, and pain. So I'm going to give you a very dense science bit in the beginning, and then it's going to turn into how you can control it, what you can do, and what it means to you. But without a fundamental knowledge of like what I'm talking about, it's just going to sound like voodoo probably. So I'm trying to get down to the science for you. All right, so what is it in general? So you can consider it you may have heard the term free radicals or oxidants. Some people say reactive oxygen species, which is technically a bit more accurate. Oxidative stress is when these free radicals or reactive oxygen species begin to outnumber your innate antioxidants. Okay, you have some that you make yourself on any given time and that live in your body. When you start to have that balance go more pro-oxidant, that's when you start having damage. Why? Because the free radicals attack DNA, they attack proteins, they attack cell membranes, and they're just inherently, they're like little cluster bombs going off everywhere in your body. But a certain number of free radicals are normal. You want to have some of them, some of these reactive oxygen species, because they tell your cells that you're in a time period of stress, and they're signaling molecules, and they do have some benefits and promote some beneficial pathways. It's when you have too many of them that you begin to have problems. And that's when you have oxidative stress, which in turn induces inflammation, which in turn causes things like diabetes, pain, cancer, Alzheimer's, Parkinson's, name a degenerative condition, and it probably all comes down to these issues. Okay, so what are free radicals, or what are these reactive oxygen species? Basically, they're the byproduct of human metabolism. So we take food, like let's say I eat a piece of an apple or a banana or something. Your body can't really use it in that form. It's like oil straight out of the ground. You've got to refine it, make it a usable fuel for the cells. But the process of doing that, on the yellow box, you get these byproducts, these reactive oxygen species. The whole thing works because of oxygen. We're humans on a planet with an atmosphere with oxygen, about 20% or so, and everything hinges on that relationship. And then we breathe out carbon dioxide and we urinate a water-based substance, urine. Why? Because those are also byproducts of this metabolic process. So oxygen allows the conversion of fuel, bananas, into usable energy, ATP, adenosine triphosphate, which is a little tiny molecule that has a very high energy bond holding on 3 phosphate groups. And when those bonds break, it releases energy. That's the usable fuel product, the gasoline, if you will, to make your car run. You would never be able to run your car on crude oil straight out of the ground, okay? It has to be refined into a usable feature. And that goes for any type of fuel out there, okay? You can't use wind. It has to be refined into a usable fuel product, electricity. And so glycolysis is a first stage of converting food to fuel. You get a certain number of ATP from that, not that many, but carbon dioxide comes off. You enter the Krebs cycle, which we talked about in a previous talk on oxidative stress. The Krebs cycle turns that fuel, glucose in particular, into a certain number of ATP. Then that goes, the molecules from the Krebs cycle, which are like NADPH and FADPH, those go to the electron transport chain, which is in the mitochondria. We've talked about the mitochondria. It's hugely important to everything in the body. Without a good, functioning, healthy mitochondria, you might as well just give it up. So the mitochondria then use what's called the electron transport chain, which involves a number of antioxidants. A number of electrons move around. They go into proteins and out of proteins, shifting a proton balance. They create a gradient along the membrane. You can see the gray lines here. That's the membrane of the mitochondria. One side of the membrane ends up with a whole bunch of protons, which are positive charge, and then the other side doesn't. And then it lets these protons drop through the gradient into the other side to even it out. Because remember, nature and humans love a balance. You can't have a whole bunch of protons on one side and none on the other without them trying to seek to even out and become 50-50. So the protons drop through this protein called ATP synthase, spin a little turbine, and create what? ATP, adenosine triphosphate. So the energy created in that turbine by dropping the protons allow the phosphate molecules to be bonded to AMP, monophosphate, and ADP, diphosphate, to become ATP triphosphate. Then, when your body needs the energy, it just adds water. The hydrolysis of adding that water molecule breaks the bonds, you get the energy. But all of these little guys, superoxide, hydroxyl, peroxyl, hydrogen peroxide, singlet oxygen, and the other two, which we're not really talking much about today because those are nitrogen species, nitric oxide and peroxynitrate. All of these are damaging reactive oxygen species that, if they are not managed and neutralized, will go on to damage your DNA, damage your cell membranes, destroy proteins, and make your cell and your mitochondria generally useless. Okay. So it was a lot, I know. So oxygen's a key, right? We use oxygen to produce energy in water. It is the final electron acceptor in that electron transport chain. So these electrons go into these proteins and they move the protons, okay, the energy as the electron passes through little bits and pieces in these proteins. They're called cytochromes. They sit in the electron transport chain. As they move through, the electrons have to be shifted around. Think about it that way. And if they get to the end of the electron transport chain and they don't have somewhere to go, it's going to be a bottleneck. It'll back up. It's almost like if a piece of machinery broke at the assembly line for making a car, we'll say. If one piece of machinery breaks, like where you add the steering wheel, and nothing happens from that point forward, the whole thing will back up. I mean, you're living that right now, right? With these supply chain issues. There's no chips. Can't make the car, they can't add the electronics, so everything backs up, and what happens? The factories shut down. Oxygen takes the electrons at the end of this transport chain right before those protons drop through the turbine, and it becomes water. So the electrons hit oxygen, it accepts it, it bonds to 2 protons, and then you have H2O, hydrogen, 2 molecules of hydrogen attached to a molecule of oxygen and water. What happens to that water? Generally, it becomes urine at the end of the day if it doesn't get recycled. And then remember, carbon dioxide was a byproduct at the beginning of the cycle. And that's why we breathe out carbon dioxide and we urinate water, because these are waste products of just staying alive. But without oxygen, it's not going to happen. But if oxygen doesn't have a perfect match to make a perfect number of water molecules, and you know there's not perfect efficiency in any system, then the oxygen will become a reactive oxygen species, okay? And then oxidative stress causes a whole host of problems. And I put this picture here to show you this is not the oxygen that you want in your life. You don't want to be dependent on an oxygen tank. And that happens because of years of chronic inflammation, oxidative stress, destroying the lung, destroying the body. And here's somebody still smoking, which is an external source of oxidative stress, while on an oxygen tank, which, by the way, is explosive. So I would never recommend doing this. Okay, so again, all of this is because we live on the beautiful planet Earth with oxygen, okay? We have oxygen in our atmosphere, and everything evolved or began on this planet, and everything is symbiotic and relies on each other. So the reactive oxygen species are free radicals in a biological system, okay? It's essentially, think of it as an unpaired electron. So if you look at the little picture, the little blue smiley face on the bottom, if you remember anything from high school or college about chemistry, about atoms, you've got the nucleus, and then the electrons are kind of like in a shell spinning all around the outside and keeping it balanced, right? And different atoms have different numbers of the core number changes, which gives you your periodic table, which gives you your different elements. And then different elements attached together and make a molecule. So oxygen has a certain number of electrons rolling around on the outside, and most of them are paired or should be paired. If they are not paired, guess what happens? Nature wants balance. So that singlet electron, that little tiny unpaired lonely electron is going to do its best to find an electron to bond with and become a pair or an even number. And again, oxygen is the final electron acceptor of the electron transport chain. But if it doesn't bind with water, then it'll become a reactive with hydrogen to form water, it will become a reactive oxygen species. And this just sort of shows you a chain of that happening. Catalase, we'll talk about in a bit, and superoxide dismutase, you can see down here, these are your innate antioxidant enzymes, okay? So you do have a certain amount of ability to counteract this that is inside of you just by design. Okay, so think of everything you do as like, we're essentially electrical beings, right? So the only reason I can talk to you right now, I can move my arm, is the same reason this computer can work and let me send the signal to you, because little tiny negative charges are moving around, and by changing the differential of charges, you get electricity, and then you can convert that into different force or different types of energy like movement, right? Or heat or sound waves or what have you. But basically, we're electric. Our nervous system is electric. Everything works in the nervous system because of voltage-gated sodium channels. And sodium is positive, right? So it's all about charges and electricity. So again, an atom is negatively charged particles, electrons, swarming around the nucleus, which is positive. Everything should balance, and it should be a neutral element based on the number of positive charges and neutrons in the middle, balanced by the number of negative charges on the outside. Okay, every molecule has a certain number of electrons, and each molecule has to be neutral at the end of the day. They must balance. Some of these are stable, some aren't. So some of them are barely hanging on to that neutrality and very easily disrupted. Some are quite stable and inherently stable. And then if you've got an unstable atom that has an unpaired electron, it is going to have a very strong need to find a pair, to find another electron. So it's either going to throw that other electron off that is unpaired, or it's going to pull something on, depending on the relative strength of the different atoms and molecules. And then sometimes two atoms will go together and actually share an electron, right? It'll like spin around in both and make them both effectively balanced, but they're not really balanced, only if they're together. And that's sort of like what we call a covalent bond. Now, in a redox reaction, which is the electron transport chain, is oxidative phosphorylation, which is a series of redox reactions. That is when one atom is stealing an electron from another to move charge and energy around. So that's really the fundamental issue. We're moving charges around to convert fuel, which is like apples, bananas, carrots, because I know nobody eats any processed food that I'm talking to. So you're only eating whole, healthy foods. You got to convert that by shifting electrons around into a usable form of fuel that can be stored and accessed when needed by the body, which is adenosine triphosphate. And this involves these redox reaction, which leaves us with unpaired electrons that can then attack us. And we're going to get into how to neutralize that. So again, just to reiterate, all electrons want to be paired. Stable molecules tend to keep their electrons. They're not going to give them up. So even if like Mr. Smith comes over and says, hey, I'm really sad. I'm an unpaired electron. Can I have one of your electrons? And I'm really stable and I'm really strong and I don't really like Mr. Smith. I'm going to say, no, not so much. I'm not giving up my electron. But if he goes to a less stable person or a less stable molecule, that one may very well give up that electron to him. And then guess what happens to that molecule? That molecule might become a free radical or just blow up or just go away. So you want stable molecules when you're in the environmental setting of reactive oxygen species. Antioxidants kind of perform that function for us, and we're going to get into that. Go back real quick. The little green smiley face or the blue smiley face, that's showing you the transfer. If you can see that empty circle, that's showing you the transfer of an electron from that unstable, upset green guy to the blue guy who before only had 3 electrons on the left side of the screen. Now he's got 4 and he's very happy. But look what happened to poor guy next to him. And that could be a DNA molecule, an RNA molecule, a protein molecule, a lipid membrane, anything. You don't want that guy floating around your body unhappy. All right. So oxygen is highly electronegative. Okay, it's a very negative little molecule, and it really, really, really wants to bring electrons into its orbit. Okay, that's probably why it's the final electron acceptor, and why everything that we are revolves around oxygen. Okay, there's a reason your lungs are the only oscillating system in the body that never, ever, ever stops. You never stop breathing, even when you're asleep. Remember how we talked last time about how sleep is so important, where the body does all of its maintenance things and it repairs stuff. You have like a plant shut down and a turnaround. Well, your lungs never get that chance because you always have to breathe. Okay. Now, because how do I put this? Because it's so electronegative and it wants to pair so badly, it'll release energy as it pulls the electron. So when electrons shift, it's similar to, think of it as potential energy, okay? Like Newton's apple. So that apple's up there, right? The bond between the apple and the leaf breaks a bit, and what happens to the apple? It falls to the earth, slams into the ground. All that potential energy goes to where gravity, because the attraction, the pull of gravity is so strong. So if you have a molecule that is really wanting to take electrons from another one, it will, and that will release potential energy. And then most of our potential energy is going to be found in food. That's where we get it. And then we take that potential energy and make it useful with ATP, where it's stored. It's super potential energy. It's like an apple hanging in a tree. And then when we need it, we break that bond, it drops down. Water is what you use to break that bond. So ATP stores potential energy in a usable form for your body so that you can talk, walk, sleep, breathe. Anything that we do, you have to have energy to do or it's not happening. And then the reactants of glucose, which is, in the apple and the fruit you eat, so it breaks down to usable functional molecules like glucose, and oxygen have more potential energy than the products of this reaction. What kind of reaction? If you remember, redox reaction. So we take glucose and oxygen, or fructose, or lactose, or whatever your food is, and oxygen, huge amount of potential energy. We spit out carbon dioxide with our exhales. We urinate water as our byproducts, but we have transferred the differential amount of potential energy into ATP in the process. Then we can use that later. And then just so you know how powerful oxygen is, just think about fire. So a candle, the paraffin wax, has a potential energy within the covalent bonds of its molecules. The oxygen pulls the electrons from those covalent bonds as the wax becomes vaporized. And as it does that, the potential energy, the difference between the bond in the paraffin wax and then what oxygen does to it, that gets released as heat, and that is your flame. So this is sort of what's going on in the mitochondria, but obviously at a much teensy tiny or microscopic scale, right? You're obviously not blowing up into flame everywhere, but that's the level of energy we're talking about that's getting produced in your body every day, all day. Okay. And obviously there's going to be a byproduct. With flame, it's going to be smoke, right? And then in our body, it's going to be reactive oxygen species. So, okay, food becomes adenosine triphosphate, ATP. That is your usable fuel. Through the electron transport chain, the oxygen is attracting the electrons, becomes the final electron acceptor. Water is formed. Carbon dioxide formed in the Krebs cycle in different parts. ATP is made from ADP or AMP, okay? You're just adding and taking off phosphate bonds as you need to store energy and use energy. And then when you need to use it, this picture is a really nice illustration showing you, you just add water and that helps to break the chemical bond of one of those phosphate groups will go off. When you break that bond, it releases the energy and then you can do whatever you need to do. So normally one oxygen molecule, we always say has 4 electrons. Technically it's got 8 really with, it's got 2 rings of electrons. So it's got an outer shell, inner shell, and then the nucleus. There's 8 electrons in the, I'm sorry, 6 electrons in the outer shell. It would really like to have 8. And then when the hydrogen comes in, they form a covalent bond. They're sharing electrons, okay? And you can see that in this little Mickey Mouse looking picture where now hydrogen has 2 electrons, right? And oxygen has 8 in the outer shell, but really they're sharing 2. So really one of them has 6 and one, the hydrogen only has 1. But this is how chemistry works everywhere in the world. One of the bonds that is super important to molecular structures and to gaining and adding electricity is by these covalent bonds whereby electrons are shared in the outer shell, okay? So oxygen will pair with 4 hydrogens, generally speaking, to form 2 water molecules. Why 4 hydrogens, you might be asking? Because oxygen is O2, so H2O. So it's got to have 2 hydrogens, okay? And then that is 1 molecule of water. But if you have 2 of them, then you're going to have H4O2, right? Which, of course, is going to break into H2O. So each oxygen molecule with 4 electrons is going to end up with these covalent bonds becoming 2 water molecules. So what if oxygen doesn't get the 4 hydrogens that it needs or the positive charge? What if it only gets 1? Then you're going to have a superoxide molecule. You could have a peroxide molecule. You could have a hydroxyl radical. So anytime you have an uneven number of electrons, depending on how many electrons or what's the uneven number, is it 1, 3, 5, 7, I guess, you're going to get these different reactive oxygen species because you don't have that nice sharing of electrons with a beautiful balance, or oxygen has an uneven number of electrons. And then remember, it's very electronegative and oxygen is going to run around and really seek to attract something. So these reactive oxygen species are going to dramatically seek to pair with another electron to the detriment of your DNA, protein, and cell membranes if you don't form a water molecule or have an antioxidant around. Okay, again, we talked about electron transport chain. Just give you a visual picture. That is the cell membrane, the little circles with the 2 little legs hanging off. That's a phospholipid group. It forms a lipid bilayer, which is fat on the inside and water attractive on the outside. That is all folded in and out through the mitochondria. And these proteins sit within the structure of that membrane and allow electrons to shift up and down and through it. And then you get protons on one side and a highly dense amount, not on the bottom. And it drops through ATP synthase, spins a turbine, allows enough energy to form a phosphate bond so that you create ATP from ADP. And then where the extra electrons go, they hit oxygen, which then binds to hydrogen that is passed through ATP synthase, forms water. But by definition, this is not going to be 100% perfectly efficient, right? And you're going to have some reactive oxygen species left over. Okay, how else would you get reactive oxygen species besides your own, that was my fireplace, besides your own metabolic system? Ionizing radiation. This is one of the reasons radiation is so damaging and causes cancer, because that in and of itself, the energy from the ionizing radiation will move electrons around and create unpaired electrons, which then go on to attack DNA, create mutations, and cause cancer. Smoking does the same thing, okay? The act of smoking, you're just basically giving yourself unpaired electrons every chance you take an inhale. So smoking is super, super big source of exogenous or outside the body reactive oxygen species. Pollution, so just water pollution, air pollution, soil pollution, there's chemicals everywhere. Terrible food like bacon, which is a highly processed animal protein product, that's going to give you a lot of reactive oxygen species. Being obese or having excess energy in your system gives you reactive oxygen species, because the human system was not developed, or it did not go through evolution with the expectation of a lot of excess energy. So that really disrupts everything, makes the whole system not work correctly, and you get a lot of inflammation and reactive oxygen species. And then chemicals and medications. A lot of medications do this to you as they're processed in the liver. A lot of the drugs that are prescription pharmaceuticals, FDA approved, will cause oxidative stress as they're processed in the liver. All right, so this is just showing you a real cool picture of the little turbine, the protein, sort of a cartoon of what that turbine would look like. And then the protons drop through, spin it, and convert that motion into energy, which allows the phosphate to be bonded, okay? It's a redox reaction, one atom stealing an electron from another atom. Food is converted into ATP through this system, okay? The electrons are moved through the membrane. The proton, the electrical gradient, is created, highly positive charge, negative, it's going to even out. The final electron acceptor is oxygen. That's why oxygen is so important, and also why oxygen becomes a problem. So without oxygen, the electrons would pile up at the end, the whole reaction would stop, everything would shut down, cell death would occur. So the oxygen has to do something with these electrons. What does it do? It shares them with hydrogen. It forms a covalent bond, becomes water. But if it doesn't do that in a perfect ratio with the amount of ATP you're making, you get reactive oxygen species. And now I think we're going to talk about how that matters. Why does that matter? Why do we care? Well, because they cause oxidative stress, cell damage. Why? Remember, I told you that an unpaired electron does not want to exist. Nature abhors a vacuum. Nature doesn't like empty space. Nature does not like anything that's not balanced. Water's always going to even out. Gravity's always going to even things out, okay? No different with free radicals, unpaired electrons. There's going to find a way for this electron to become a pair with another electron. It will bond with structures in the DNA and break bonds in the DNA, or glom on to certain molecules in the DNA, or it'll do it to proteins. It'll cause proteins to fold improperly, or it'll cause proteins to degrade and denature, we call it, and just kind of fall apart. And then also that lipid bilayer, that little picture I showed you before with the little round circles and the dangly legs doing like this, forming a cell membrane. Oxidative stress really likes to get in and disrupt the cell membrane. And you can imagine, how could a cell exist without a wall, right? If it's not enclosed and protected from what's around it, how can it function? How can anything go on in there in any sort of an efficient manner? It can't. So if you destroy the cell membrane, you effectively destroy the cell. And then just to review the chemistry again, oxidation is the loss of an electron. So this is rust. This is when your bananas turn brown. This is when your vegetables rot. This is wrinkles. This gentleman up here, this shows you a young man with good skin, lots of muscle, oxidative stress, sarcopenia, time, damages, and you end up with that picture. Okay, healthy muscle, as it converts down to unhealthy muscle, things thin out, the mitochondria become inefficient, you can't produce fuel correctly, you can't fold proteins correctly, your DNA becomes a big mess, and then reduction is the gain of an electron. Okay, so free radicals damage the human body, we know this. To what extent, we're not sure. Some of this is needed. You need it for signaling molecules to allow the body to know that it needs to do certain things. For instance, if the body didn't have an ability to sense energetics, it would never know when it needed more energy or less energy. You know what I mean? Like, you can't just have the electron transport chain always spitting out the same amount of energy. That doesn't make any sense. So the body has certain ways to manage that. And that's why having too much energy is a problem. The system doesn't really know what to do with that information. Okay, and these are different free radical species. So oxygen, O2, there on the top, a superoxide anion, you see one is gone, or one unpaired electron, I should say. peroxide, hydrogen peroxide. Hydroxyl radical is extremely damaging to cell membranes, and then the hydroxyl ion. There are some nitrogen-based radicals too, and that's from the protein species that we convert to fuel. I'm kind of leaving those out today because this is already too complicated, I think. It's hard for most people to understand, including myself, but it's super, super important. And then lipid peroxidation, okay? That is when your cell membranes are destroyed. Let's talk about that briefly. Initiation, propagation, termination. The problem with lipid peroxidation, which is one of the ways we measure oxidative stress, by the way, is that it becomes a chain reaction. So one of the bonds in the fatty acids in the lipid bilayer will become a reactive oxygen species or have an unpaired electron. And unless that's neutralized immediately, it does it to the next, does it to the next, of the next. It becomes a self-feeding cycle and it spirals until the cell is no more. So this is, you really need to stop lipid peroxidation. So the lipid membrane we talked about, it's a phospholipid molecule. You've got the fatty acids that then attach to like a choline group and a different phosphate group. And then if one side is going to be hydrophilic or like water, and the inside is going to be lipophilic or only like lipid type structures or fatty type structures. So this is how it kind of protects itself from the outside environment and only lets in what it needs or what it wants, okay? So the primary molecule of your lipid bilayer is your phospholipid group, keeps the cells intact, okay? It's got a hydrophilic region as the head, okay? That's the water-loving region. It's polar, phosphate molecule with some additional molecules occasionally. And then the tail is your fatty acids. They love fat. So fat-loving on the inside, water-loving on the outside. It's a bilayer. It's a beautiful structure. Periodically, you're going to have receptors and different proteins and different voltage-gated channels that let things in and out as needed. Okay. So that's what you don't want to destroy. Here's a beautiful picture showing you the receptors and different molecules as they sit within the lipid bilayer. The little yellow squiggly things are supposed to represent cholesterol. You do want a certain amount of cholesterol. It maintains flexibility of the cell. Omega-3 fatty acids maintain a better, more functional, more flexible cell membrane. In addition, as we said before, the portions of the fatty acid that then will become part of a inflammatory pathway is needed. If it's an omega-3, it's way more beneficial to your body than if it's an omega-6. We've talked about that before, and probably we'll have another talk about that soon. So the cell membrane puts the hydrophobic molecules next to each other, the hydrophilics next to each other, creates basically really a 3-layer protection system. And then some molecules can just pass through if they are able to react with both the water-loving and the fat-loving side. Big ones have to go through a receptor that either says yes or no based on the ligand or ligand, however you say it, the key that opens the lock. So there's different proteins around that'll attach to a cell membrane receptor and either open it or not open it. And then again, cholesterol is necessary to buffer and space and maintain fluidity. Okay, so when you damage the integrity of that bilayer, you damage the integrity of the cell. It can't work correctly. Okay, imagine if you had a factory without walls and a roof. The rain, the wind, lightning, looters, cars would cry. It would just be a disaster, right? You wouldn't be able to make anything at that factory. You've got to have control around your factory. The cell is your factory, the mitochondria being the engine, okay, making energy. So this just gives you an idea of the complex nature of the lipid bilayer. And this is not just a flat sheet, it's a cell. So it's like kind of like globby, circular-ish. Oh, we got a question. Sure, I'll take one. I need a break too. It's a lot of science. Okay, the question is from James, what tests would you ask for to test oxidative stress? This is a great question. I'm currently working on this project right now to find the best way to test it. There are some urine byproducts from the oxidative stress pathway, I guess you could look at. You can look at advanced glycation end product in the skin with fluorescent testing. I think there's a way to measure lipid peroxidation with one of the reactive oxygen species that comes off of it. The short answer is I can't find a simple test yet that's covered by insurance that I think would be really beneficial, but I'm really working on it right now. Now, the inflammatory test is a little bit easier to do, like IL-6, tumor necrosis factor, alpha, and those elevate when there is more oxidative stress. You could check your metabolic level, your hyperglycemic level. It blacked out on me. But that is a good question, James. I'm working on that. I'm trying to come up with a good short test list that's covered. And it may turn out that it's not, you know, it maybe have something that people have to pay cash for, which is kind of sad. But that's the world we live in, unfortunately. But I will get back to you on that. But basically, right now, it's easier to check inflammatory levels than it is to check your oxidative stress levels. Hold on, I'm having a technical error. Hold on, we have a blank screen. There we go. All right, go to the next slide. Yeah. You don't see it. Oh boy. My producer is not seeing it. There we go. All right. So how do free radicals cause the damage? So again, you have an unpaired electron, right? Oxygen with one of those odd numbers of electrons created during the course of making fuel for our cells. And then that makes the molecule quite unstable. So this reactive oxygen species is then going to go on to attack something like the cell membrane, pictured here on the bottom. And as the free radicals attack the cell and damage it, it'll make the cell membrane more permeable, punch holes in it, make it less flexible. It won't work, it won't move right. And then you'll end up with a very damaged looking, non-functioning cell that doesn't have the correct receptors. It lets things in that it shouldn't be in. It lets things out that shouldn't be out. And then the reactive oxygen species can get in and worse, cause damage to the DNA and the proteins. And it's essentially just a chain reaction. So think of lipid peroxidation like when your oil goes bad, because that's what's happening. So if you go eat at a restaurant nowadays, I would bet you that they are reusing their cooking oil over and over again to save money, especially in the setting of hyperinflation like we have right now. And so each time you reuse the oil and heat it up and process food through it, the oil gets more and more lipid peroxidation, because what is oil after all? It's a bunch of lipids. So this is like when you have really good, beautiful, green, almost translucent olive oil, and then it becomes like brown and smells bad and rancid when it sits in sunlight too long or it sits in your closet too long. That is the process of lipid peroxidation over time. That is going on in your body as we speak, if you're not neutralizing the oxidative stress. So if you want to know what oxidative stress is doing to your body, think of used cooking oil at the fast food restaurant by the time the sixth person rolls through the drive-through. Probably don't want that in your body. All right, so oxidative stress damages DNA, proteins, lipids. We already talked about that. When it damages proteins, it'll create amino acid modifications. Okay, amino acids are the basic building blocks of protein, like leucine, lysine, those little molecules that are out of meat, if you will. But you can get plenty of protein from things like shiitake mushrooms and edamame. Shiitake mushrooms actually have all 8 essential amino acids that you need. And then these damaged proteins are what are called advanced glycation end products. That's one type of damaged protein. You'll get a buildup of those. And part of it just blacked out. If you have anybody that is diabetic in your family or you're diabetic, you've probably had your A1C checked, okay? Hemoglobin A1C. All that is looking at is how many advanced glycation end products have glommed onto your red blood cell over time, which is indicative of the level of hyperglycemia in your blood, because the sugar molecules attach to amino acid groups in a bad way and form these monster proteins that then glom on to the hemoglobin. And you can gauge by the number of these altered proteins, you can gauge the average blood sugar in the past 3 months. So like, if your A1C is 10, your average blood sugar has been 240. That's why we try to get people down to 7 and 6, because that's closer to normal. 5 is really probably where we should be, because that's 97-ish, 97 to 123. Okay, that's your range. And then a A1C of 6 shows you your average hyperglycemic level, like 120 to 150 or so. So you get these weird proteins or modular proteins that damage functionality. Or you get denaturing or proteolysis, which is just like breaking apart the protein bonds and the whole thing just falls apart. And then enzymes, which are these are little molecules that allow chemical reactions to happen in the body. Either they promote the reaction or they stop the reaction. Enzymes are hugely important. They're like little catalysts. They'll get denatured and degraded by the oxidative stress because the electrons go in and they say, hey, enzyme, I need your electron, take it. Then that enzyme can't function anymore. And then, of course, DNA damage, which creates mutations or breaks apart the DNA or takes off the endings or changes the telomere length, and then that causes aging, and then cell death. So again, we already said lipid peroxidation is oxidative stress to the cell membrane, damages the lipid bilayer. And this causes what? Like you can't have fragments of a cell membrane floating around that aren't part of a cell membrane. The body senses that and thinks something's gone wrong, there's an injury. So what does it do? It sends an inflammation to clean up the debris, to reduce the damage, to where's the pathogen? Where's the attacker? I need to get him. And then guess what that does? More inflammatory proteins come in, little chemical messengers that send out the signal, hey, we need to inflame this area. And then what happens? You get chronic inflammation. So low levels of lipid peroxidation occurring from oxidative stress over time induce chronic inflammation because the body wants to clean up this mess that happened. And the mess happened because nobody ever neutralized these unpaired electrons. There weren't enough antioxidants around. And then there's damage to the organ. So your cell membrane, again, super, super important. We've talked about it at length. Think of a wrinkle as damage to the cell membrane, okay? But really, it's way worse than that. I really think you should think of it like the used oil. Nobody's using olive oil at a fast food restaurant. They used really bad oil to begin with, as it's been destroyed by the sixth person that came through, and that's your French fries, which you shouldn't be eating those. But that just gives you a picture of it. Okay, so DNA damage, what happens here? Well, DNA is a beautiful structure, right? This is the coding, the signaling that tells everything what to do, when to do it, how to do it. DNA forms RNA. RNA then helps code the proteins that need to be formed, okay? So if your DNA gets messed up, even one base being removed, okay? So you can see that here. The top DNA line, TGC, ACA, blah, 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 will code for the RNA, the messenger RNA. The RNA will then code for the proteins. So the ACG becomes threonine, UGU becomes cysteine, so on and so forth. Well, let's say you have an unpaired electron that comes in and it attacks the T in the DNA, removes that out, changes the code completely, and look at your protein list. It's totally different from that point forward. So you have now created a whole new structure that wasn't really supposed to be there. So DNA damage, DNA mutations, that's why they cause cancer. It really messes up everything. So you really don't want unpaired electrons anywhere near your DNA strands if you can help it. And then you can have single strand breakages, nucleotide degradation. That's what those letters are. They're the nucleotides. And then you can get even crosslinks, extra crosslinks to different proteins because of this and form more advanced glycation end products. So we really want to stay away from DNA mutations. Okay, this is why a lot of people believe antioxidants help with cancer, because cancer is DNA damage or mutations. Now, I'm certainly not going to sit here and tell you that taking an antioxidant will prevent or treat cancer, but at the fundamental level or the base of what causes a DNA mutation, I think it makes sense. There's a lot of work being done on this, of course. There's a lot of clinical studies going on using antioxidants such as turmeric or curcumin to help treat different forms of cancer in conjunction with other treatment methods, of course. So the double helix is made of bases and sugars. Ribose is what the sugar's called in DNA. And then the addition of an oxygen atom to one of those bases, a reactive oxygen, will damage it. It'll oxidize it, right? The oxygen glommed on. Guanine, the G of the coding letters, which is the base, guanine, I think I'm saying that correctly, has the highest oxidation potential. So it's going to be the one that's going to be usually mutated. And then following that, cytosine, adenosine, and thymine as well. Any of these can have point mutations just from a single unpaired electron. It's kind of scary. Beautiful thing is your body has a way to manage a lot of this, but we just get into this where we're not balanced. And then that's when mutations happen, lipid peroxidation and protein damage. So the whole point of taking antioxidants or eating a healthy diet is to upregulate the antioxidant to make it balanced again. Because in our life, with this ionizing radiation, heat, different drugs, pollution, a terrible diet, highly processed foods, we have tilted our balance heavily in favor of oxidative stress. And the goal is to get it back to balance, okay? So we're always seeking balance here, and I think hopefully this is going to help you understand why. All right. So again, here's your guanine molecule, so the base of the oxygen, and then it has a reaction with a free radical that's floating around, and just that single gets oxidized. You just add that little negative charge on the oxygen there, changes it completely to a completely different molecule, which doesn't function in the same way, and you have a mutation. So it doesn't take much, right? But it does take a lot of work to combat this. You do have to change your diet. You do have to live healthy. You cannot have excessive energy. And you need to protect yourself with things like sleep and basically good living, good, clean living. So what does it feel like? So if you have oxidative stress, so imagine your lipid bilayers in your brain are all messed up. Your DNA is getting mutated all over the place. None of your proteins are working right. Your skin is getting stiffer and wrinkly. Your hair is getting grayer. Things just don't feel good. You're fatigued. You've got muscle aches. You got brain fog. You periodically have headaches. Nobody knows why. You just feel inflamed and hot. What's going on? That is oxidative stress. That's how it feels. Now, I'm not saying if you have all that, you might not have some name diagnosis that your treating physician would tell me I'm crazy and want to treat. I'm not going there. But I just want you to know that this is very damaging stuff, and you really do need to think about it if you care about wellness. The mitochondria need to function properly. They have to have a perfect membrane. Everything needs to work well. They've got to have oxygen as a final electron acceptor, and they've got to have a way to neutralize a reactive oxygen species that it doesn't need for signaling. Okay, some are needed. You don't want to neutralize all of them, but you need to have a balance. Otherwise, everything will fail. Okay. So what causes oxidative stress? We talked about ionizing radiation, talked about smoking, pollution. I mean, you could imagine how ingesting a chemical might create a couple unpaired electrons and damage things, right? So lack of sleep. Remember, your body does all of its maintenance work at night. If you don't sleep enough and you don't get to do the maintenance and the cleanup and take out damaged cell membranes, repair damaged mitochondria, fix mutations in the DNA, because your body does have a certain capacity to do that. If you don't give it the time to do it and it doesn't happen, you're just going to have a cumulative effect of damaged cells over time and more unpaired electrons. So sleep is hugely important to human health. Poor diet. This is probably the #1 reason our medical system is in disarray, I'll say. Why people are so unhealthy. I'm in Louisiana, which we trade off every year being either the 49th worst in health or the 50th, like not a good thing. Like we're always the most unhealthy state or close to it. And a lot of that is because of poor diet, lack of exercise, and excess energy. Okay, we have a very high diabetes rate here, almost 30–40%. Same with the obesity rate. And even a lot of the children in Louisiana are obese now and starting to get diabetes in their preteens and teenage years. All of this is why? Because of poor diet. Totally controllable patient factor, right? You have to eat foods high in antioxidant phytochemical content, berries, leafy green vegetables, sweet potatoes, carrots, things with beta carotene, which is a lipid-soluble antioxidant, cherries, blueberries. And then you got to avoid the highly processed foods that have been processed to the point that they have advanced glycation end products and worse, cancer-causing chemicals in them. Pollution. The harder your body has to work to detoxify the air you breathe and the water you drink, well, what's it going to do with the normal oxidative stress that it creates during metabolism? It has no way to neutralize that. So we just live in an excess pro-oxidant world, and we have to manage it better, I think. And then mental stress is a huge cause of this. Mental stress releases cortisol and fight or flight hormones, which then upregulate a lot of the metabolism and downregulate protective things. And then, and I'm talking about chronic long-term stress, okay? Short-term stress is actually beneficial. Long-term stress, not so good. You have a pro-oxidant balance. So one thing that people have learned, and there's actually some data out there that shows that the only thing that's actually reduced cardiovascular death over time is meditation, believe it or not. More effective than statins in some studies. So transcendental meditation in particular, by way of the breathing and controlling your thought process, reduces oxidative stress and actually has been shown to extend lifespan because it's reduced insulin resistance after just 16 weeks of practice. significantly lowered the levels of lipid peroxidation, reduced blood pressure, and reduced cholesterol with absolutely no change in the diet. And remember, some cholesterol you need, right? Your brain needs it, cell membranes need it. So you don't want to be cholesterol free. You just want to have good cholesterol. So the psychological stressors cause oxidative stress by changing the sympathetic tone and changing just sort of the basic functionality of the mitochondria over time, where it produces too much energy at too high of a rate with no neutralization. But mental stress is interesting, and I'm learning more and more about this, and I'll bring it to you as I understand it more. If you can control your mental stress, chronic long-term mental stress, it's very helpful to lifespan, health, and longevity. Oh, we have a question. A tough question. Oh boy. How do you reverse long-term stress? Great question, because I struggle with this. I have a stressful job, a lot of responsibilities, and I deal with it all the time. I've tried to start to do little short-term bouts of deep breathing. There's box breathing, where you breathe in, inhale deeply, hold it for a certain amount of time, and then exhale for the same amount of time. If you just do that 5 to 10 times, just doing that box breathing seems to reduce stress. Yoga reduces long-term mental stress. And then really, I think you just have to start thinking positively. So, and that's a whole process. Some people end up needing to get counseling to help with long-term mental and life stress. But the simple things to do are eat better, because if you eat better, you can combat it a lot. If you sleep, you can combat it. And then if you do the box breathing, transcendental meditation, which does take learning, and you have to have a coach to start. And then things like yoga, which has been shown, probably because of the pranayama or the deep breathing in yoga, that's been shown in many studies to reduce anxiety and long-term stress. Or, if your life's too stressful, you may have to make some changes. It's one of our problems in modern times in America. It's very stressful. And that is a great question and very difficult to answer. And then, of course, you want to just, if you can't manage your stress, but the byproduct is reactive oxygen species, at least try to manage the byproduct while you're managing the stress until you get your balance right. So I try to eat very healthy and sleep. I've been trying to drink more water to assist with the systems, eat a lot more omega-3s and 6s. I take omega-3, and then I take a lot of antioxidants to try to handle the stress. And then I just started doing box breathing. And then walking. Exercise is one of the best ways to manage stress, actually. And you don't have to go to CrossFit, and God forbid. You can really just take a walk. And then one of the biggest, most important things for longevity, health, and wellness is muscle. And you need more muscle, because muscle helps to pull glucose out of the blood without insulin, okay? It doesn't need it. As long as muscle's working, it'll pull glucose out, even if you're insulin resistant. So this is why exercise is one of the hugely important ways to reduce stress. Also, remember I told you long-term stress is bad, but short-term stress to the system is good? So exercise is one of those short-term stressors to the system, okay? Just like jumping in an ice bath. That's kind of trendy right now. Stresses the system, reduces inflammation. But short-term, you're not living in an ice bath. Or you go in an infrared spa. Same thing. Heats you up, stresses you out. So all of these short-term, shock it. If it doesn't kill you, it makes it stronger. That's the theory of short-term stressors. That helps. But with these long-term stress situations, you just need to eat a really healthy diet and take a lot of antioxidants until you can get it under control. So what are the antioxidants and how do they help? So you know about vitamins A, C, and E, CoQ10. Glutathione is the one you make in your body, and you can also get it through an IV treatment. You can measure the levels, as James pointed out before, and then you can measure the byproducts of glutathione, which really show you where you're at. So there's a certain ratio of glutathione before and after it neutralizes a reactive oxygen species, and you can measure that ratio, which shows you the activity of the glutathione reductase. That's another way to do it. So your body will neutralize these things, but if you don't have a way to recycle your glutathione, or you don't have the right building blocks to make glutathione, you're in trouble. Alpha lipoic acid is a great antioxidant that I take every day. It's lipid and water soluble, and it helps glutathione to regenerate itself. That's why it works so well. So metal carrier proteins, so anything that you can put in your body that picks up extra reactive metals like iron. There's a lot of data out there now showing that excessive iron in a system promotes oxidative stress, because there's just a certain type of chemical reaction that happens between a highly reactive metal positive ion species with the electrons. So if you can chelate the metals with metal carrier proteins, you're helping yourself. Transferrin, ceruloplasmin, plasmin, sorry. I have one of our supplements, the multi-system for the nervous system, has chlorella in it, which is a green algae, and it chelates metals. Okay, superoxide dismutase is one of the enzymes you make yourself. Catalase is one of your enzymes. Glutathione peroxidase. So your body does a lot of this on its own. Now, your body cannot make vitamin C. You do have tocopherol in the lipid membranes, which is vitamin E. Vitamin C, if you take it, will help the vitamin E to regenerate. And then things like beta carotene help prevent lipid peroxidation. So if you've got this defense system going on, right? If it becomes overwhelmed and the invading army is bigger and stronger, eventually you're going to sustain damage, correct? I mean, we see this right now. So you have to have enough of a defense system to fight the massive onslaught of oxidative stress that we are facing in this world today. And I personally don't think I have enough, so I take extra when I can, and I doubt most Americans do unless they're eating a perfect diet and have no stress and nothing to worry about, and they're also breathing different air and drinking different water. I just think it's impossible to avoid a lot of this excessive oxidative stress nowadays, especially if you're on medication. As I said before, even Tylenol can cause oxidative stress in the liver as it's processed. So the antioxidants, sorry, just real quickly. No, you can go to the next one. So the way the antioxidants work, and this is some deep chemistry that I confess, if I had to take a test right now, I'm not sure I'd get 100 on it. The antioxidants, the way their outer electron shell works, they have the ability to take on another electron, right? Or to give up an electron. If they give up the electron, you would think, well, doesn't that make that antioxidant have an uneven number of electrons? The answer is yes. But the way their chemical molecule is, the way the electrons move in the outer shell, it's still stable. So even though the antioxidant loses an electron and neutralizes a free radical or a reactive oxygen species, it is still stable, and it does not in and of itself become a reactive oxygen species. But at that point, it's used up, and unless that is recycled and regenerated through another chemical reaction, you got to replace it. And that's why you got to keep eating healthy foods and taking antioxidants, okay? So your vitamin C will regenerate vitamin E. Your vitamin C will reduce cytokine bursts and will help to protect you from the damaging reactive oxygen species that are produced when you fight off infection. So vitamin C is one of the big ones, I think, that we take. It's water soluble, so a lot of people take it every day. Now, some people believe in cycling this stuff. So you take vitamin C sometimes, you don't other times. You take vitamin E sometimes, you don't other times. I think you should eat omega-3s all the time. But there's different theories on how to take this, how to dose it. Honestly, there are no long-term, really well-done studies, in my opinion. I mean, they look at this stuff for like a year or two, maybe. It's hard to look at somebody. You can't take one group of person and give them antioxidants and another group and not give them and look at them for 30 years. It's just impossible. But the one piece of data we do have is looking at people that live in the blue zones or people that ate the traditional Mediterranean diet, which we know are very rich in antioxidants and omega-3s. And those are good sort of indirect long-term studies that show the power of this balance of oxidative stress. If you can balance it, you will live longer and have less disease and be healthier as you age and have more vitality. So these are your antioxidant-rich foods, okay? What? Oh, we have some antioxidant-rich foods in this little picture I put here. Pecans, nuts are good. Berries are huge. Anything with sort of a dark, colorful pigment in the natural world indicates that the plant has created an antioxidant to protect itself from things like UV rays, pesticides, bugs, venoms. So blueberries are awesome. Strawberries, raspberries, blackberries, boysenberries, tart cherry, yeah, tart cherry, duh. That's my favorite product. Tart cherry has a huge amount of antioxidants. Dark chocolate, usually it has to be over 70% cacao. The cacao bean is extremely antioxidant. Green leafy vegetables. And we don't have on this picture any of the orange foods like carrots and sweet potatoes, things like that, but that has a lot of beta carotene, also antioxidant. Kale, dried prunes. I mean, basically, I mean, you know this, you are what you eat. You've got to eat healthy, whole, organic, not filled with pesticides and chemicals, fruits and vegetables to get enough antioxidants to fight off the damage. Okay, and then we already talked about relieving your mental stress. If you can't change your life, like right now, as I told you, my life is pretty stressful, but I can't change it right now. I don't want to. I love teaching. I want to keep educating the public. It takes a lot of time. And of course, I have a million charts to do and still have clinical responsibilities. And I teach for LSU and I'm all over the place. But the box breathing, sleeping well, making sure you stay hydrated and taking antioxidants can help relieve the mental stress. Improving your sleep and diet, I can't stress it enough. Really just trying to get good 8 to 9 hours of good sleep each night. We have some sleep gummies now to help with that, with melatonin, gabapentin, CBD, tart cherry, different things that not only help reduce the hyperactive glutamate and hyperactive nervous system at night, but also help the body to detoxify or clean up the debris at night. And then, of course, taking alpha lipoic acid, CoQ10. I didn't tell you, but CoQ10 is very important in that electron transport chain. It moves electrons from one of those proteins to the other in 2 of the steps and is very, very important and is also an antioxidant in and of itself. So if you don't have enough CoQ10 around, then you will end up with more reactive oxygen species during that process, okay? Because the CoQ10 can act as an antioxidant and move electrons. Okay, so again, what can you do to protect yourself from that old used cooking oil that's going on in your body? Mediterranean type diet is my personal preference and what I believe in. I think it has a lot of data. I think it's approachable. I think it still allows you to be social and have fun with your friends and family. And you don't have to, be super type A and you can still be healthy. Making sure you eat a lot of polyphenols, terpenes, flavonoids, things like resveratrol, NMN, which is a precursor of NAD+, and I never say this word right, anthocyanins, which is what's in tart cherry extract and the darker berries. That's a flavonoid or phenol that is very antioxidant. That makes no sense. It's antioxidant, so it reduces your pro-oxidant balance. Cannabinoids are very antioxidant, okay? Micronutrients, hugely important, things like zinc, magnesium, all the phytochemicals we're talking about. And you could get all this just from eating a Mediterranean diet, but you're not going to get enough unless you get the 9 servings of fruits and vegetables that are recommended. Taking glutathione, you can get that IV or oral. ALA, which is alpha lipoic acid. NAC, which is N-acetylcysteine, also very antioxidant, very good for the brain. CoQ10, extremely important to move electrons along the energy pathway and also to capture the extra electrons. And then the different herbal molecules like curcuminoids, it's being studied for cancer treatment now. Allium sativum, which is in garlic, which we know is extremely healthy and also reduces platelet aggregation. Silymarin, which is, I think, in the family of the resveratrols. Beta-glucans, which are in the mushrooms, very helpful for the brain as a phytochemical and micronutrient. So those are the things you can do. And then you must avoid smoking. It's good to avoid radiation. Now, I know of some scientists that don't even go through the airport X-ray device, right? Because they don't want that much radiation. Now, I'm an orthopedic surgeon, so I'm around X-rays all the time. I wear lead, I wear a thyroid shield. But at the end of the day, I'm still around radiation, probably more than most people on the planet. So again, I have a need to take extra antioxidants, which I do. Pollution, I mean, I can't tell you enough. Pollution's a big problem, and you should be involved or at least know how much pollution is in your area. Bad oils, you can only eat, or I think one of the best things to eat is the first cold press extra virgin olive oil. Okay, that's going to have the most antioxidants, the most polyphenols, the fewest oxidized molecules, and is the best for you. And it also has oleic acid, which we think also upregulates certain ones, which are longevity molecules in the body. Okay, avoid processed foods. Those are made with high heat. More advanced glycation end products are created. And in some meat products, cancer-causing chemicals are created during the processing mechanism. And the mental stress, we've talked about that. So that's the things you avoid. And then the things here, Mediterranean diet, micronutrients, antioxidants, and herbal molecules, that's what you do. And exercise. What? Okay, we have some questions. So, okay, this is a question we get a fair amount, or I do in my clinical practice. What supplements should I take if I'm on a fixed income and I can't take them all? Well, first, you got to change your diet. So processed foods seem inexpensive, but at the end of the day, they're not. Remember, the lifetime cost of a heart attack is about $750,000 if it's a severe heart attack. So trying to avoid that heart attack will make you more wealthy over time. Okay, so the first thing is to spend your budget and try to find the healthiest foods, and avoid highly processed foods, and try to cook your own foods, like make your own beans from the dried beans, make your own bread if you can do it, which is pretty inexpensive. I make my own bread, flour, yeast, whole grain flours, yeast, etc. But anyway, in terms of the supplements, I think probably the most powerful one is probably alpha lipoic acid, and then turmeric and tart cherry, those three. So the tart cherry helps a lot with pain. So a lot of people with chronic musculoskeletal pain, they get on the tart cherry, they just feel a lot better because they don't hurt as much. And then the CoQ10, hugely important. Again, we talked about that, especially if you're on a statin. So if you're on a statin, I would go with the CoQ10 gummy that we have, because the way the statins work is they stop your body from making its own CoQ10 too. And so you get a lot of muscle pain, a lot of oxidative stress, ironically. The alpha lipoic acid, because it's both water soluble and lipid soluble, so it's very good for nerve health. And then the nervous system multi is also very good. But if you had to pick one, I would go with the oxidative stress reducing, I guess, gummy, which has a CoQ10 and tart cherry in it. Okay, that's a good way to get those two. And then ALA, I think, is probably hugely important, particularly if you have any type of neuropathy. And then probably turmeric. Turmeric just has such a strong history of helping with many facets of human health, especially pain.
So the next one is there a multi available that includes all of these?
Is there a multi that includes all these? No. There's a few reasons. First of all, again, back to the fixed income question, that would be really expensive. And as you know, our medical system doesn't care about wellness, health, or prevention, and none of this is covered. So you're going to have to come out of pocket for this. But at the end of the day, I think it saves a lot of money because, again, you're going to avoid that trip to the ICU. You're going to avoid that pneumonia. You're going to avoid that heart attack. You're going to avoid the peripheral arterial disease, and God forbid, amputation, things like that. So staying healthy ultimately lets you accumulate wealth over time. I guess, did that answer the question? Oh, yeah. And then there's some physical barriers to putting it all in one multi just because of the size that it would have to be. Because you have to have a certain number of milligrams of each substance, and each substance has to have a salt or a carrier. And then you've got to have a molecule in that keeps it from oxidizing. Usually we use ascorbic acid, which is effectively vitamin C. So there's only so much you could pack in a capsule. And then some of them don't mix with each other. Like omega-3 is an oil. You can't pack that with something that's not lipid soluble. So you have to pack them different ways and then make it something that you could actually swallow. It has to be a certain size. So there's really no way to do it all in one. Just like there's no one food I could tell you to eat that would give you everything. You really just have to come up with a package, I guess. Yeah, the nervous system multi, it has a 2 capsule and a 2 gel capsule dose. So 2 of the capsules are oil-based with the omega-3s in it, separate from the 2 capsules that have like the resveratrol, the chlorella, the N-acetylcysteine. Okay, so you separate them out that way. Another question. This question is, why does diet soda interfere with weight loss? So I think that's probably controversial because there's a lot of data going either way. The gut biome has the ability to sense sugar. It doesn't necessarily follow that the gut biome or the bacteria within your intestine actually find the stevia molecule or the sacchar molecule or whatever. There's so many of them, I can't remember. Monk fruit doesn't necessarily mean that your gut biome notes that that's a fake sweet, but it may not note that it's real sugar either. I don't know how to answer that question. There's not enough data to answer that question because some people drink diet sodas and don't gain weight. Some people drink diet sodas and do gain weight. One of the problems with diet sodas is the phosphates really over time. A diet soda periodically is probably okay. I mean, I drink Diet Coke periodically. I can't find anything that's really strong evidence to tell me it's terrible. I mean, again, what you want to live your life and be happy, right? And get along with your friends and have a nice stress-free life and like enjoy your life. Every now and then you're going to do something that you really like that may not be on the list of amazing things for you, right? Okay. You might like to race cars. That's not really the safest thing in the world, but periodically you might want to do it. You might want to go rock climbing, great exercise, high risk. You may not want to do that, but it's great exercise and you like it. Diet Coke once in a while, I think it's okay. I don't know that it necessarily makes people gain weight because you'd have to see everything else they're ingesting with the Diet Coke, right? And some people think a Diet Coke makes the Snickers bar they're eating okay. I'm not saying that's you or anybody you know, but the studies just aren't super strong in that world. Another question.
Karen's been taking our supplements for a while, but she's added a systematic enzyme blend. Is there any reason to believe that is it okay? Is it safe? Repair or not?
So Karen said she's been taking supplements for a long time now, but just added a systematic enzyme blend and asked if that's okay to take. I would say it's probably okay. I would have to see exactly what enzymes, and then like, do you take it on an empty stomach or with food? And then you would maybe just want to time that, right? Like, so for instance, if you're taking the turmeric that we have, generally you want to take that joint health multi with like something a little bit fatty, like egg or milk or something, so it absorbs better. And then the pepper that's in that supplement will make it more bioavailable, but it still has to get through the gut. The systematic enzymes may require an empty stomach. Like ALA, it's generally recommended to take on an empty stomach. I mean, there's different ways to maximize or optimize, I should say, absorption of these nutrients. But I don't think once in the system, once in the human body, they'll interfere with each other. They'll probably help each other, I would imagine. Okay, 2 more questions.
Can I take CoQ10 with sulfur allergy?
Can I take CoQ10 with a sulfur allergy? That's a good question. If you can eat garlic and onion and all of the sulfur carrying foods and do okay, I would imagine you could take CoQ10. Now, I can't offer medical advice, of course, in an online webinar. I would probably talk to your physician, but CoQ10 has a sulfur molecule in it, but so does garlic and so does broccoli. Basically, all of the bad smelling foods have garlic in them, okay? I'm not garlic, sulfur. So if you're okay with those, you're probably okay with CoQ10, I would imagine. And glutathione has sulfur.
She started taking our tart cherry at night, but it doesn't make her sleepy, so she ordered the tart cherry gummies. And she take them both together.
This question is, can I take the tart cherry extract and the tart cherry gummy together? Yes. So the tart cherry extract's 1,500 milligrams. I think it equates to like 150 tart cherries if you ate it straight. Some people take 2,000 to 3,000 milligrams of tart cherry a day. I recommend on the low side just because it's always better to start low and add as your body tolerates it. Every single person on this planet is different. Even though the insurance companies think that you're all exactly the same and require the same exact treatments, that is not true. You're all different. So your system might just need more tart cherry. I take the gummy and tart cherry at night personally. Sometimes I take 2 tart cherries because I found out my uric acid is a bit high recently. So, you know, I mean, you got to do what you got to do, test it, make sure you're not interfering with any of the meds your doctor has recommended. And of course, caveat, you always got to check with your treating physician, but I think that would be fine.
Also, can you just talk about like the different levels of sleep aids we have? So like if one not working, we have different
Oh, yeah, so we have different sleep gummies, again, along the same principle that not everything works for everybody. CBD, or cannabidiol, is one of the greater sleep aids. So I give recommendations for medical marijuana to the patients I treat sometimes. And the number one bit of feedback I've been getting is it helps them sleep, which does what? Allows their body to clean up, detoxify, get rid of oxidative stress, and then they generally start feeling better and have less pain. Narcotics will not do that for you, but THC and CBD do that for you. So CBD is awesome for sleep. It tamps down some of the neural receptors. The gummies have GABA in it, which is sort of like gabapentin. You guys might have somebody on gabapentin or Neurontin in your life. The way that works is it tamps down the excitability of glutamate, which makes nerves jump and process more. So if you can tamp that down, you calm the whole system down. That's how GABA works. Tart cherry, the reason that helps is it detoxifies because of anthocyanins, but also has a bit of melatonin in it, which is found in that pigmented shell of the tart cherry. So we actually have a gummy with melatonin and without, because some people react differently to melatonin, and it's actually paradoxical. It keeps them up. So if you're not responding to the one with melatonin, try the one with CBD. If you're not responding to the one with CBD, try the one with melatonin. And then there's a delta 8 THC that's great for sleep, but if you have any sort of HR issues where you get tested, it'll show up positive for THC. So I wouldn't recommend that, but it does work well for sleep. And then, of course, avoid blue light. Try to be active during the day. Have a glass of water by your bed, hydrate, and try to keep the room dark and cool. Coolness helps a lot, 65 to 68 degrees, and you will sleep better. So hopefully that sort of gave you a sense of why we do what we do or why I believe what I believe. Now, I'm not saying that I'm any kind of anti-aging expert or anything like that or wellness expert, but I'm trying to be. I think I'm starting to get there, but I learn more every day. I'm going to bring it to you as I learn it. There's a lot of work being done in the genetic modifications of life and longevity, okay? So like add in mTOR and sirtuins and whatnot. But the antioxidants, I think, are huge, and reducing inflammation stress is huge. I see it every day. It definitely causes pain and stiffness. If I can control that, a lot of my patients' pain and stiffness goes away. Definitely helps with sleep, definitely helps with reducing incidence of disease. We see that on the long-term studies in the Mediterranean diet and blue zones and whatnot. So I think this is hopefully just gives you sort of the groundwork or the foundational principles and why you might want to take some antioxidants in addition to changing your diet. Any other questions? What's that? All right. So again, CoQ10, very important, helps maintain your levels of ATP and also reduces muscle statin pain, or I should say statin-associated muscle soreness, SAMS. There's actually a name for it. So it reduces that. We are going to have a giveaway for people on watching the webinar right now. So the Oxidative Stress Gummies, which has the CoQ10, the tart cherry, and chaga, which has the beta-glucans. That's one of the mushrooms. That's very good for brain health and a very strong antioxidant. So that is a great mix that you should be on. All of us should be on. We all need more CoQ10, but especially if you're on a statin. And then alpha lipoic acid, which remember I told you is both lipid and water soluble, and is a very powerful regenerator of glutathione. So I think we're going to give these away to somebody on the talk today, and hopefully you understand more about what is oxidative stress. It's reactive oxygen species, which are unpaired electrons, how that works at the fundamental atomic level, and what happens to your body in terms of lipid peroxidation, DNA mutations, and protein aberrations or protein changes, and how that might mess up your system and cause disease, pain, stiff tendons and ligaments, damaged cartilage, brain fog, fatigue. And there are ways you can help yourself, and you don't have to rely on going to the doctor, going and sitting in a waiting room, going to the ER and trying to get some sort of strong painkiller. You can manage this yourself over time if you just control the oxidative stress and inflammation. All right, the giveaway is going to go to 2 giveaways. So Margot Grubbs is going to get a giveaway. Hopefully you're still listening, Margot. And then, yeah, and Sandy, who shared the talk a lot. So thank you, Sandy, because I think the more people that know about this stuff, the more I think you'll understand why medicine doesn't seem to be helping anybody in a general way, why America's always seems to still have very unhealthy people. And, you know, this is why I think, or one of the fundamental reasons why, and we're not addressing this at all, probably because it's preventative and you can't, I don't want to get into the politics of it, but I think there's a lot of politics as to why this stuff is not taught and why people don't understand this. So I'm trying to give you guys what knowledge I can.
watch the video on the Facebook page or any of your websites?
Okay, so this video will be put on our Facebook page and any of the websites. So the Healing Soul, the Well Theory, and then Warner Orthopedics.
Margo says, yeah, I have your flip-flops.
And Margot has the Healing Soul. Good. The Healing Soul is where I started this whole self-empowerment, natural medicine quest, because I've basically created a flip-flop that lets your body use the body's ability to heal to make your foot pain go away, rather than having damaging injections or surgeries you don't need or imaging you don't need, et cetera, et cetera. And it's been awesome for people. And then from that, we've sort of blossomed into this sort of natural self-empowerment quest, I guess, of mine. And hopefully we're helping some people out there. So thank you. Thanks for watching.